Hello, thank you. So, like JB said, we're the biggest ever ADC this year. There are 400 of you this time. That means we're not quite as big as the My Little Pony convention, but I was glad to find out that we are bigger than the Homeopathy Research Conference. And if next year we can grow just a little bit, maybe get to 600, we're going to be almost as big as the Flat Earth Conference that happened last week. And I'm quite glad we didn't clash with that, because I'm sure a lot of you would have gone there instead. So we've got a room full of 400 clever and expensive people to entertain. And it's great for me to get a free pass every year to come here and talk about whatever the heck I want. But it does mean I have to come up with a good topic every time. So looking back at previous years and thinking what to do, I did notice a bit of a pattern here. So I seem to alternate between doing a talk on some random topic and a talk about me banging on about whatever random thing I've been building for the last year. So it would have been really easy to come up here this year and bang on about Soul again. But I have the kind of brain that can't break a pattern. So I wanted to find like a blue sky, non-self-congratulatory subject to do this time. So what to do? I kind of thought maybe a good approach would be to pick a catchy title and then work backwards from that. So this would be an absolutely killer talk, but couldn't figure that one out. I reckon I could do this talk. I reckon this is possible, but it would take several days to actually give the talk, and not many of the audience would survive it. Maybe next year if I'm stuck. But while I was thinking along these lines and trying to come up with useful tricks and tips to share with you, I started kind of introspecting about the thought processes that I use when I'm working, trying to see, when I'm really on a roll and everything's going well, what am I doing? What's going on in there? And no, I didn't come up with any amazing original tips that aren't already in 100 great How to Be a Good Programmer books. And if you want that standard How to Be an Awesome Programmer talk, then go see Pete Goodliff, and he does a much more visceral show than I can put on. But I did think of a sort of interesting angle to all of this that I'd never really thought about before. And it seemed like something that would be fun to explore today. So, coding with your cave brain. Early picture of Richard Stallman there. Now, the Flat Earth Conference may have more people than we do, but I think we have more of this stuff in the room, or at least you know how to use it better. We do a lot of useful things with our brains, including writing code. But back when our cave-based ancestors were helping to evolve this thing by getting themselves eaten when they didn't use it correctly, or they weren't living in an environment where understanding what a monad is or being able to invert a binary tree on a whiteboard would have been really that helpful for their survival or reproduction. We had Neanderthal tribes, they probably fought each other over things like access to clean drinking water and not so much over tabs versus spaces. But they did manage to evolve 100 billion neurons that we can play with. So, thanks for that, dead ancestors. That's much appreciated. But they didn't evolve as a general purpose processor. It's very much a many-core heterogeneous package that we've got. And most of those 100 billion neurons are pretty hardwired to do specific jobs, like seeing, hearing, chewing, not falling off things, panicking, trying to get laid, that kind of thing. It's like monkey-level stuff, lizard brain stuff. But with these monkey brains, we've managed to quite successfully build really enormously complicated, non-physical, very abstract systems. The systems that follow artificial rules that have nothing in common with the kind of environment where the brain's evolved. And we've only had a few generations of humans since we invented computers. And as far as I know, we've not been selectively breeding for geeks on a farm somewhere, unless that's maybe what campuses are for. So we still have this old-fashioned brain. But I started thinking, what tricks are we using to get it to do all these alien tasks? Now, memory experts have known for decades how to do these mind hacks where they can memorize a million digits of pi or whole phone directory. And nobody really can just do that stuff. They use these cunning memory tricks where they they take advantage of skills that we're just innately good at, we have a lot of capacity for. So they create visual associations, they create stories, images, mnemonics, to store raw data and to map it into the form of concepts and images that your inner monkey finds really easy to remember. And then you get the monkey to remember the images, and then you translate them back to the data. So I'm kind of musing today over whether we have our own set of tricks that we kind of consciously or unconsciously do to help trick our monkey brains into helping us do coding tasks. Now, I do have a psychology degree. It was 30 years ago, and I'm a little bit rusty, but I'm going to give you just, I think, mostly remember how the brain works. So I'll give you a quick sketch here where I've given, these are the basics. Now, we did actually evolve some logical, rational, abstract thinking ability. It's up there in the front left cerebral cortex, about here. Now, some people obviously have more or less of that, maybe through genetics, maybe through doing more of it when you're young and your brain's all plastic. It's a pretty safe bet that this room is going to be full of people who are higher than average in their logical thinking ability. I think people who have absolutely loads of it won't be here because they're the pure mathematicians and the physicists, and they go to conferences like DAFX rather than ADC, where they have the really difficult math stuff. And people at the low end of the spectrum, they end up doing jobs where nobody expects you to be rational, so politicians and things. But this logical bit of your brain, I think this is where this is the bit where that you use to mechanically crunch through a problem. So if you're doing some really painful step-by-step rule-following task, this is the bit that has to do it. And that's an indispensable chunk of the brain for all of us programmers. Like working on Sol this year, Ches and I kind of come up with a name for the days where you're using this bit heavily. We call them wet tea towel on the head days, where you've kind of got a really tough problem and you have to take a deep breath and say, okay, I'm going to plod through this and my head's hurting. You spend hours picking through something, you eventually come away with hopefully the solution and a bit of a headache. We've had more than our fair share of those this year compared to anything else I've worked on. And they leave your left frontal cerebral cortex feeling a little bit tender. But if all programming involved just doing that all the time, then I think A, we'd all burn out in about a month and go and do something easier. And B, we'd be making really poor use of our available hardware. I mean, if you're having a huge multi-core server, you don't want to run all your work on one core, one thread in Python, do you? So, because when you're using just the number crunching bit of your brain, it's the other 95% is just sitting there like a bored monkey. It's kind of waiting for the logical bit to finish so it can go and do important monkey stuff like scratching your bum or trying to get laid or having a sandwich or something. And definitely when I kind of introspect about how I work mostly, it's not all that headachy stuff or the really focused work. I mean, everyone knows here, like when you're really on the flow with something, you're in the zone. You're not just following rules. You're kind of, it feels like you're doing something much more holistic, much more human, much more artistic. And the monkey brain is joining in. The most productive times are when you have lots of different things buzzing away in parallel in there. So I'm going to share a few thoughts on how these other more primitive bits of brain might be helping us out. So something we did evolve to be really good at is dealing with stories and narratives. A good story makes it effortless to learn sequences of events and consequences of events, and to build mental models of characters and how these characters might behave. And we evolved that skill to make our tribes work well together and to learn and transmit skills down the generations and to increase our chances of getting laid. And most memory tricks, they involve representing random data as memorable objects. And for most coding problems, the trick is to convert your jumbled collection of kind of requirements and outcomes into a single coherent story. It's why when you're talking through a problem with your rubber duck or a patient colleague, it can be really effective. Like if your rubber duck or even your colleague can understand what you're telling them, then you can understand it too. And once you've created yourself a story that you can understand, that's most of the hard work done. So I see myself doing this when I'm rubber ducking. It might take a few restarts, but eventually you'll come up with a way of explaining the thing you're trying to do. You'll build a plan in your head, and if you can bake it down to a couple of sentences, okay, we're going to build a graph of all these objects, and then we're going to iterate them to find the ones, okay, it's this one, we can mark those and take a copy for later and throw away the ones, blah, blah, blah. And then you've kind of got that little story in your head, then you can go and do that. And until you've got that story in your head, I find I can't actually write the code. And if the story's too long or too complicated to easily remember or follow, then that's a sign you need to break it down into smaller steps. And that's when you switch from storytelling mode into boss mode, and you're delegating to your duck. You're saying, okay, duck, you're going to create some new classes over here to do this job, and some to do this job, and they're going to do this job, and then you create stories for those little chunks. Now, obviously, you'll all immediately see what this program does. If you can't see at the back, it's a text editor. In fact, this is the complete source code for a text editor written in the K language. Now, K is actually it's not a niche thing, it's like a very widely used language in some industries, and there's a company, KX Systems, who sell this, and it's a massive company. But I'm kind of using it here as a scapegoat, as an example of what coding looks like when you take away all human language from it, and just keep the data itself. And I think when Alexa or Siri finally reach the artificial intelligence tipping point and they gain consciousness and they go off to write code to destroy humanity, they're probably going to write code like this. I mean, they're also not going to waste their time pressing the space bar, are they? So here's a shorter bit of K. Obviously, this prints the numbers between 1 and R, as you can tell. I'm going to contrast that with what I've written here, a deliberately over-verbose bit of code that does the same thing. And I've been trying to put in as much human language as possible without doing comments. So these are sort of opposite extremes of wordiness, really. But I think the time you spend staring at each one of these to figure out what it does is probably quite similar. If you're looking at the squished up mathematical stuff, your eyes don't move much, but you'll have to mentally pick it apart. And I don't know about everyone, but I have to kind of pick things like that apart and build a story in my head and explain it in words before I can really get to grips with what the author was trying to make it do. In the long-winded version, there's much more of it to look at. It takes you longer to read it. But if you can if you can write this stuff well, you can kind of guide your reader through it so that by the time they've read it, it should have already narrated itself in their minds without them really having to do much work themselves to get to that point. And this is why good naming is important. You have like countless neurons in your brain just sitting there, and they have one job, and that job is to wake up when they see a particular word and to trigger all kinds of associations with that word. So if you see a word like a symbol like X or Y, it doesn't have any inherent meaning. So when your brain sees it, there's not much really happens. It says, oh, there's an X, a mathematical X symbol. A word like error is going to do more. It's going to wake up bits of your brain that say, hey, this might be a bad thing. And it's going to tell you a bit more than that. A word like count is going to tell you, hey, there's this number of things involved here. Don't know what the things are. So that gives you a head start over just X and Y. But if you go the whole way and use phrases for your naming, then you're kind of triggering whole chunks of meaning, which you otherwise have to infer from the context. So as an error occurs, not only tells you there's a bad thing, it tells you that it's a Boolean, and it's like it's telling you whether something's happened or not. And it probably only takes half a second to read a long phrase, but once you've read it, you're ready to go. And if you just see an X or a Y, it might take you many seconds or years before you can work out what the hell the author actually meant it to do. Vision. Now, we have loads of neurons for vision. We have tons of stuff for interpreting what we see, and we do a pretty reasonable job of making use of them in coding. Here's some code that's too small to read. Don't bother trying. I just took a random bit of code from my code base, and I removed all the color and spaces from it. Now, when you sort of glance at something from a very great height like this, it tells you nothing really about the content. So what I'll do is I start adding back some visual cues, but without actually changing the text and without trying to read it at all. So add some line feeds, and hey, we can start to see a structure. It looks like a class, and there's some methods in there. Let's make it follow the Juice coding style, and we add a bit more breathing room between some of the words. And I know you all love that space before the arguments, but it helps us break the symbols up into discrete chunks that are visually discrete, even if you can't read what they are yet. And then let's line things up. Lining things up helps to sort of group related things together. So before you even get as far as working out what they are, like there's some related stuff here, especially vertically. I do like doing things vertically, because that's stuff that isn't necessarily obvious. So in this one versus this one, we can see, there's actually a whole pattern of data in there that you couldn't see first time around. And add a bit of color, and for the syntax highlighting and all the literals and the class names start to pop out a bit. And maybe you can read it, but if you don't even try and read what it does, you can still get some good clues. So you can see there are some virtual methods in there. There are some probably related methods that all seem to be returning a Boolean. I can see a couple of functions that choose between some strings, and there's some enums, and there's an enum at the top. And I really do recommend squinting at the page when you're doing coding like this, because when you're kind of navigating around your code base and it's getting quite big, and you're kind of madly scrolling up and down looking for that important bit of code that you can't find anymore, being able to pick out visual landmarks like this really helps to get your visual cortex involved in a way that it would otherwise be sitting there useless. And to be honest, I've always felt it's a bit of a shame that we don't go a bit further than this. It'd be great to have more 2D layout involved, rather than just blasting out a program in a linear stream of text. It'd be nice to put boxes around things and colors and move things around so that the position on the page actually had some information, but tricky in a text editor. So, because social skills are so important to humans, even coders, we have loads of neurons dedicated to understanding people and animals and things, so that we can predict behavior, know how they will react to things, and that helps us not get eaten and increase our status in the tribe and that sort of stuff. So even the most antisocial geeks have plenty of capacity for mental models of characters and group dynamics. And I don't know if it's just me, but I do find myself, when I'm talking about code, I find myself using very anthropomorphic terms about it, especially if I'm trying to describe a problem or debug something. I say things like, so this guy here with the variable x is going to be bothering these other objects with some messages, and it's going to be bombarding these guys over here. But they're going to be busy doing this other thing, and there's something else spinning away in the background here. And it's all like little characters running around doing things and interacting with each other. And they you as you work with objects, you start to give them traits. So you have big, clumsy singleton classes that kind of live a long time and take a while to get going and warm up. And then you have swarms of little short-lived objects like buzzing around like insects that do simple tasks. Some objects have their fingers in too many pies and need to be told to mind their own business a bit more. Some classes are very geeky. They just do like one super complicated job very well, but they're not very helpful around the house. Some classes you trust, this thing's never going to go wrong. Trust this one. You're always wrong about that. Others are kind of delicate snowflakes. You just you don't want to go near them and touch it. You might break them or upset them. And we sort of navigate with human terms as well. Animals are. It's very helpful for us to have evolved the ability to remember where things are in relation to other things. It helps us not get lost and end up, in a random, dangerous place. And when I listen to myself debugging, I also noticed that I sort of described the journey you're making through code in very human terms. So, we came through here, we hopped over this bit, we got stuck down there for a while, and then we sort of tripped over this expression here. So how did we get over here without going through this bit? There's a shortcut. It's all very navigational terms that we tend to use. And as your imaginary timeline is sort of traveling along, it's going through often a very varied landscape. You've got, sometimes you'll notice the same landmarks. You keep passing them, and there are bits of boring desert where not much happens. You're just sort of stepping, nothing very boring. Other bits it's like working your way through a tangled rainforest, and there's lots of dangerous things in the bushes to avoid. And I've always had a really bad memory for real geography. I'd like to imagine that's because I'm using all those neurons for remembering code paths instead, but I don't think it works like that. We appreciate nature a lot as humans. When we see a beautiful landscape, it's our inner cave person is telling us, this is a good, safe place to be. You can find food and water and fruit here, and start a family and have strong children, and they'll be safe from the monsters. As geeks, we've kind of generalized that response. So when we see a beautiful piece of code, your brain's telling you it's a good, safe thing. It's not going to, you're not going to get laid there, but at least it's probably not full of lurking monsters. And making that aesthetic judgment is something you get better at over time. Like eventually, you want to end up as that tribal elder who can pick out the good bit of jungle that's going to be just right for the tribe to colonize. People who sit near me in the office will know that I like to use various types of anger in my work on most days. There's the sort of high level, oh my God, this thing is complete crap and it's driving me mad, I'm going to sort it out, do it better. And that's the kind of anger that sort of drives you to do stupid things like writing a door or something. The sort of more simple, practical type of anger is just getting annoyed with yourself that you can't fix this bug or figure something out. And that's useful, for making yourself stick to things when your front left cerebral cortex is getting a bit warm, and just the other monkey brain is saying, go and have a biscuit. And you sort of, the anger can help to keep the heat on the cortex until you get to the end of your problem. But being human is not all good. We have weaknesses. Now, I don't have any superstitious habits, touch wood. Obviously, though, when you're new to a domain and you're building up your mental model of what the rules are, you're inevitably going to make a few ropey inferences about cause and effect before you start to get everything straight in your head and understand it properly. But experienced coders, we get superstitious too. You often hear people saying things like, I don't really know why this works, but I've always done it that way and it's always been fine. And to be honest, in a way, being irrationally afraid of things you don't fully understand is probably quite a good trait. If more C++ programmers got spooked out at the sight of a raw pointer, we'd have a lot fewer bugs in the world. We're tribal, and that's good and bad too. It's practical to form groups like AEC today, where people doing related work can come together and share and learn. On the other hand, it's my mic on. On the other hand, it's dangerous to overcommit to the mic working. Is that working? Okay, so to overcommit to any set of values. Although to be fair, we don't suffer that too much from like programming fundamentalists. There's the writers in Rust brigade, but they're pretty harmless, really, aren't they? Being dogmatic about things is another double-edged sword for humans. The best programmers are tediously dogmatic about the low-level details. They rigorously stick to the best practices at the small scale. But the really good ones know where to draw the line, and above the higher level aspects, and know to be more lateral when they think about those things. If you follow the old-fashioned church of C++, you'll know that the committee can occasionally hand down the papal doctrines of good practice. Sometimes they update their advice to keep up with the modern world. But they tend to focus on what's the best thing to do with the nitty-gritty. and they're mostly very hands-off about what consenting adults choose to do in the privacy of their own repositories. You get more modern languages that are a bit more totalitarian now, and they have enforced coding styles and libraries of state-approved functionality that you have to use. And people who defend these things to the death. In designing Sol, we kind of tried to build a language where we had a safe padded room in which people can feel like they're free to throw themselves around and make a mess and bash their heads on the walls, but where there aren't really any sharp objects, so they'll actually be fine. So it's the illusion of freedom. Cognitive biases. Oh, I love cognitive biases. I had such fun reading the Wikipedia list of these for this talk. And I picked out a few favorites. You could do a whole talk on this stuff. Confirmation bias. This is classic bias. This is where you bend or ignore new information to fit with what you want to believe. So flat earthers and psychics and horoscopes and nonsense like that. And this gets us into trouble as coders when you're debugging and you just have a bad feeling about something. I know I've wasted, I don't know how many countless hours over the years after making some incorrect assumption about where a problem might be, just because I had a sort of hunch about, oh, it's that thing. I've never trusted that bit of code. I reckon it's that. And then you step through and you and everything seems to be confirming this, and you're just trying to prove it because you really want to nail that thing that you don't trust. And eventually you kind of have to take that step back and go, oh, it was something else altogether. I don't know if you ever grow out of that. I think as you get better as a coder, your hunches get better. So you trust your hunches more, and then you get stuck on them more. I don't know. I think, whether you're more or less vulnerable to that bias with experience, I'm not sure. The bandwagon effect. Everyone is using Node.js. It must be great. Everybody's using machine learning. I can definitely find a way to crowbar that into whatever the hell I'm doing. It's definitely going to help. The Dunning-Kruger effect. This is the tendency for unskilled individuals to think that they're better than they are, and experts to think they're worse than they are. This is think about raw pointers. Like beginners just innocently use them. They don't know how dangerous they are. They're fine, raw pointer. Experts who really, really understand why they're dangerous, they don't trust themselves to use them safely, even though they probably could use them safely. So they stick to smart pointers. If you're sitting there thinking, no way, I'm an expert. I use smart pointers, raw pointers safely all the time. I don't need those stupid smart pointer things. Then this is your bias. You're wrong. But to be honest, I think if this didn't exist, and if everyone who starts learning to code actually appreciated just how little they know and how much there is to know, then would you really bother carrying on? I think it's best to start off innocent. Hostile attribution bias, the tendency to interpret others' behavior as hostile. The computer hates me. C++ is maintained by malevolent members of the Illuminati. Apple keep deprecating these APIs just to make me do more work. Loss aversion and the sunk cost effect. This is the tendency to avoid loss more than to seek gain. So next time you push some commented out code into your repository, because you never know, maybe one day you want to go back and use that code again, then this is your error, stop it, delete the code, move on. And when there's that code that you'd really quite like to refactor to make it easier to maintain in the long run, but it's a bit delicate, you might break something, so I'm not gonna risk this going wrong. Often you're completely right, but you kind of have to know how to judge how realistic your risk aversion level is when you're making that kind of decision. Normalcy bias. This is the tendency to plan for a normal outcome and to fail to plan for the outliers. So it's fine. That mutex will never get locked for very long. What could go wrong? Or, we need to do a file operation here. It'll be fast. It'll never take too long. Or, oh, this function returns an error code, but we can ignore that, it never fails. Or, hey, we should use this SDK. Apple will never deprecate it, it'll be fine. The backfire effect, this is a good one. This is where something should change your beliefs, but actually does the opposite and strengthens them. So this is why Trump is in power. And and for the coding example I can think of is that I'm so tired of hearing people banging on about how great Rust is that I almost kind of want to avoid it on principle now, even though it's probably amazing. Choice supportive bias is the tendency to remember your own choices as better than they actually were. So, stuff like, oh, no, when we updated Xcode on the CI server just the day before release, that worked out pretty well in retrospect. Because, we had to fix that stuff anyway. And, I wasn't going out that evening, it was fine. So actually, that was all fine, that was all good. Outcome bias is the tendency to judge a decision based only on its eventual outcome. And that's just test-driven development. It works, so the code's fine. There's nothing else to do. Walk away. I love this one. This is the IKEA effect, which is the tendency to value things that we build ourselves too highly. We all do this. I think every product I've ever created has been driven by me being particularly vulnerable to this one. I mean, I write a library, for God's sake. Parkinson's law of triviality, otherwise known as bike shedding. We don't do this, do we? We don't focus on trivial things and ignore the big things. I think when Cher's comments on how much time I spend fixing the white space in his commits, he thinks I'm making this error. But just, I don't know. No, that's not trivial stuff. That's important stuff. And surely the king of all biases is the bias blind spot, which is the tendency to see biases in other people and not yourself. Brilliant. I mean, this is basically every thread on Hacker News and KVR, isn't it? So, do we have any incredible abilities that we're not using? We have loads of them. Hearing. We really waste our sense of hearing. We're here because we all do audio. I'm an audio developer. I hardly ever actually listen to the sounds that my code makes. My home studio over the years has dwindled to the point where I don't even have a pair of speakers set up on my desk at the moment because I so rarely have to listen carefully to what's going on in the code I'm writing. And I don't know if it's just the circles I move in, but it's definitely a trend that there's an awful lot of coders who sit there all day with headphones blasting themselves with niche metal genres. And my kind of theory on that is I think maybe the distorted white noise helps to keep the monkey brains subdued while they're focused on the logical stuff. Kind of like beekeepers with the smoke guns, kind of pacifying the bees. It's like just, there you go, monkey, white noise. But I was trying to think of what we could do to use hearing more and to make use of it in what we do. I've no idea. I mean, you could come up with ideas about adding sounds to give you feedback about errors and status of your code. But imagine how annoying that would be. It'd be annoying enough on your own in an office full of bleeping computers. It'd be just incredibly annoying. 3D is a puzzling one. I mean, surely by now, we should all be writing code in VR and pulling objects around in 3D space to build these complicated things like in the sci-fi movies. In theory, this makes total sense because our brains are built for the 3D world. That's what we evolved for. We have amazing spatial awareness, and to use it would give us a whole extra dimension to play around in. But nope, Vim is still infinitely more popular than the kind of wacky coding environments that the VR folk have dreamed up so far. Will VR coding ever replace text-based coding? I mean, it kind of feels like you should assume it will eventually because it does offer more bandwidth to interact with the data and just so many more possibilities than the straightforward text, very one-dimensional text format. But why is there no sign of this happening? My theory is that its usefulness is outweighed by the primitive urge not to look like a pillock with a bucket on your head, standing there waving your arms as imaginary monsters. Or perhaps Vim's secret is that it only requires you to make tiny finger movements whilst reclining in a lazy boy armchair and not have to actually make the effort of standing up at all. Or maybe just when you're wearing a VR headset, it's too hard to eat pizza. Humans, we're really good at face recognition. Like, we're almost as good as Facebook. Except for me, I actually have a terrible memory for faces, which is kind of my way of saying here, sorry in advance for all the people I'll meet at the conference whose name I've completely forgotten and whose faces I've completely forgotten. It's nothing personal. I've just recycled some of those face neurons into recognizing important stuff like incorrect white space. But trying to think of how we could use this, I mean, other than happy and sad face emoticons on our CI server build status pages, I can't really think of any ways that we use faces. Is there an opportunity there for some sort of app that reads your face shape and translates that into code somehow? That would be, that sounds terrible, but imagine how funny it would be to visit an office full of people doing that. But certainly our least exploited ability is for dealing with cute cat pictures. The average human has billions of neurons, whole categories of brain hormones triggered by kitten pictures. Can we think of a way of harnessing that power to improve coding workflow? Come on, if anyone has an idea, catch me at the conference. I'll drop this audio nonsense and we'll revolutionize the industry with a whole generation of feline IDEs. Humor is a bit of a puzzle. Now, code isn't really funny. I've been a lifelong nerd about both comedy and programming, but I've never found a way to make real code funny at all. There's loads of humor and banter in the developer world, but it never makes it into the code, especially not if you ignore the comments. I've written fake code to try to be funny. I did an April Fool joke a few years back where I wrote a homeopathic stack class, and to be honest, I think that's the proudest, most satisfying thing I've ever written in my entire career. But it's not real code, and in real code, I've never managed to make anything remotely amusing, and I've never really tried. Unfortunately, I think that's because jokes only work once. You could write, a class where the structure and the naming of the class, it creates like a laugh out loud funny moment, but that's the first time you read it, and by the time you've actually used it a few times and stepped through it in the debugger going, oh God, where's my bug? That joke is going to get very tiresome very, very quickly. So it's a shame because it would be wonderful if we could actually laugh while we're coding. So, are there any take-home points from all this? I think it's really interesting to look at how our tools and our habits inevitably sort of end up fitting in with the way our brains are hardwired to act. That's probably why procedural languages have ended up being more popular than the functional ones, because they tell a story, they walk us through something that we can understand rather than just creating mathematical concepts. And it's why people like me constantly bang on about how important it is to use good naming practices and consistent style that we can recognize. I think if everyone was just a bit less human and a bit more logical, then none of that stuff would really matter and everyone could just get on with writing Haskell and be dull. Are there any downsides to spending years and years of your life forcing this monkey brain into doing unnatural tasks? Well, we're all the results of that experiment, so you can draw your own conclusions over the next couple of days as to whether that's a good or a bad thing. But enough. You all want to go and stretch your legs and drink coffee and try to impress the other tribes who've come from faraway lands to this gathering. Maybe you have a new spatialization algorithm that might impress one of the powerful tribal chief leaders. Maybe you will join their tribe and go and move to their village and have strong children and eat a lot of fresh fruit. So I'm going to stop there and let you all get on with the monkey business of the conference. Have an amazing couple of days, and thank you very much.
We do have a little bit of time for questions, but I don't know. Is there any question for Jules? There is one. Okay, we're going to bring you a microphone.
Hi, Julian.
Hello.
Jeremy here. When you pull an all-nighter when coding and you stop thinking verbally and you're flying through things, I find it's possible sometimes to debug code simply on site. You can page down through a listing and just know on one particular page that's where a bug is. What do you think's actually going on at that moment?
It's pattern matching, isn't it? I know exactly what you mean. You kind of, when you've seen enough bugs and they've stuck in your mind because of the trauma of fixing them and panicking about them, you kind of learn to spot the danger patterns. It's like there's some leaves in the jungle and there's a shape moving behind them, and you pick out, oh, that's a tiger. It's the same kind of principle. Like you're whizzing up and down, all this code is flying by, and you go, oh, hang on, something was wrong there. And I know what you mean. You sort of see something, you don't quite know what it is, but you go, oh, definitely, there's something jumps out. And yeah, it's just all those big layers of neurons just doing pattern recognition at a level that you're not really consciously aware of, I think. But yeah, that's a common experience, I think. Any more? I can't really see very well.
Any more questions?
I don't expect many questions. I mean, what's it? It's not a very technical talk to ask questions about.
All right, well, I don't see any reason to delay the coffee then.
Yeah.
So let's give a big thank you to Jules again.